Let's talk about sets and Venn diagrams in a way that will give us a, well, deeper understanding, as the name implies. We're going to be coloring some in this. We're going to be filling in some charts, talking about some of the new notation, which is not going to be too out of the ordinary. It's basically subtraction, but you'll see it in this context. So let's just jump in. You're given these. There's a universal set 1, 2, 3, 4, 5, 7, 8, 9, 10, 12. And they gave us E, which are the even numbers, in case you care, and T, which are the numbers that are divisible by 3. So what we're going to do is just plug things in the correct place. Let's actually start by labeling one of these circles as T and the other one as E. I did not put those in the order that they were listed here, but that's okay. Oh well. I better not make any mistakes because my whiteout is halfway across the room too. All right, here we go. Let's put some numbers. I like to start in the middle first. Let's put some numbers there, and I'm looking to see what numbers belong in this circle and this circle, which will be the stuff here in the middle. And that would be 6, and that would be 12, which makes sense because, again, these are the even numbers, and these are divisible by 3. Divisible by 3. And so numbers that are divisible by 3 and by 2 are 6, 12, 18, like that. So 6 and 12. So we're going to put the other even numbers here. So 2, 4, 6, 8, 10, 12. There they are. They're all accounted for. And the numbers that are divisible by 3 will be over here, like 3, 6, 9, 12. Now, we also need to deal with all the numbers that we didn't list that are in our universal set. So 1, 2, 3, 4, 5, 6, 7. I'm just cramming them anywhere I can find a spot. 8, 9, 10, 11, 12. Okay, now let's answer some questions. And we have dealt with some of these in the past, but we're going to go a little bit deeper today, not with the first few, but when we get to about number 13, 14, you'll see where this is going. So E intersect T. I want to see where E and T intersect, and that would be 6 and 12. So this is kind of a review. Nothing too drastic there. E union T is everything that E and T have in common, which not in common. E and T all thrown together, the union of both sets. So it's not 1, 5, 7, and 11. So it's 2, 3, 4, 6, 8, 9, 10, 12. So not 1, 5, 7, and 11. Okay, E apostrophe is everything that is not in the E circle. We've been through this. Feel free to skip through this part of the video until we get down to about number 13. So here's E, but I don't want E. I want everything outside the E circle, so we're not going to have even numbers. Basically, I'm asking for odd numbers at this point. So 1, 3, 5, 7, 9, 11. Now, we might be tempted to say, oh, what's outside E? And you would go over here to 3 and 9. That's great, but these are not in E either, so let's not forget those. Okay, what's not in T? So tell me every number that's not divisible by 3. So 1, 2, 4, 5, 7, 8, 10, 11. Notice I skipped every third number. Not a coincidence. Okay, E intersect T, but not really. E intersects T at 6 and 12. So basically my answer will not be 6 and 12. It's everything else. So I'm going to list all the numbers except 6 and 12. What I'm really doing here, this is a good practice in basic number theory. What I'm really doing here is listing all the numbers that are not divisible by 6. Maybe we wouldn't call this number theory. 1, 2, 3, 4, 5, not 6. 7, 8, 9, 10, 11, not 12. Almost put a comma. It's not. It's a parenthesis, not a bracket. Yeah. Okay. E union T complement. So complement that E union T. Why E union T? You look nice. Kidding. Wrong form of complement. Wrong spelling of complement too. Okay. E union T is here, and I want everything else, which would be 1, 5, 7, 11. Okay, just to talk about this. These are odd numbers, and they're not divisible by 3 either. So throwing that out there, just saying. So like 3 and 9 aren't in our list. Okay, now we get to a new one, and it's subtraction, but it's sort of not. Okay, so E minus T. And I'm going to start coloring a little bit here, very, very gently, and I'll erase what I do. So E minus T. Here's E. So here's E. There it is. But I don't want all of E. I want to subtract out anything in the E circle that belongs to T. So this goes away. So my final answer for E minus T is 2, 4, 8, and 10. So yeah, you can think of it as subtraction. You're subtracting a piece of a set. So 2, 4, 8, 10. Okay, let me subtract what I wrote. And by subtract, I mean erase. There we go. Okay. All right, T minus E. So I'm not going to color this one. I don't feel like erasing again. But T is the circle, of course. But I'm going to subtract, I'm going to get rid of anything that does not belong, or that does belong to the E circle. So 3, 6, 9, and 12, yay. But subtract away or get rid of the 6 and the 12. So my final answer will just be 3 and 9. So if you want to put this in practical terms, these are odd numbers that are not divisible by 2. Okay? All right, now we're going to do the same thing-ish. So T minus E complement. So what we just dealt with was 3 and 9. Okay, 3 and 9. That was the answer to T minus E. But I want the complement of that. So it's everything else. It is 1, 5, 7, 11, 2, 4, 8, 10, and 6 and 12. So T minus E was 3 and 9, and then the complement is everything else. And we're going to put these in numerical order. 1, 2, 4, 5, 6, 7, 8, 10, 11, 12. Okay, same idea here. E minus T, once again, here's E. We subtract away the T, and that gives us 2, 4, 8, and 10. That's great, but I don't want those. I don't want those because I want everything except those. I'm covering them up with my finger, so I can do 1, 5, 7, 11, 6, 12, 3, 9. Not in that order. Feel free to, but I'm not going to put them in that order. 1, 3, 5, 6, 7, 9, 11, 12. Okay. That introduces you to the subtraction with sets.